Welcome to this Fundamentals Lesson Plan series on walls, layout, design, and editing. In this video, we'll take a look at placing walls to create a simple architectural floor plan. This is video 1 of 6. My name is John Harridge, and I will be your host for today's lesson. Let's look at the learning objectives for video 1. At the end of this lesson, you will be able to draw both straight and curvilinear walls at the inception, apply direct distance entry method techniques for defining the length of a wall during placement, apply wall orientation flip grips for walls that are already in place to change the facing or orientation of exterior materials, create similar walls of like kind to place new instances in the project, draw a continuous series of walls with the chain function enabled, and last, apply alignment constraints to walls to capture design intent where it is needed. With that, let's get started. Let's begin this lesson by creating a new project using the architectural project template. So go ahead and choose architectural template on the projects section there. Before demonstrating this exercise, I would like to introduce you to some Revit wall terminology and behavior before we begin this exercise in earnest. First off, Revit is a tool that supports building information modeling, that supports design, drawings, and schedules in a project database. Also, Revit is a parametric modeling tool that provides the opportunity to create relationships among elements of the model to enable coordination and change management. We will see some evidence of this in this exercise. Walls are a type of systems family or model element that represents 3D geometry. Furthermore, walls are a type of host element, meaning that hosts other model elements such as doors and windows. Please watch this instructor demo to show and share insights of walls before taking on this hands-on exercise. Let's begin by exploring where the wall tools are located. If you click on the Architecture tab, you'll see that there's several wall placement tools accessed through the pull-down menu, and you'll note that these are disciplinary specific, starting with architecture, structure. So if I select the architectural wall tool, this allows me to move down into the properties palette and take a look at the available wall types that are in this particular template by clicking on what's called the type selector. Type selector displays all the wall types and variations per category within this view. You'll note that there's exterior flavors for that specific purpose that have specificity, as well as generic walls that act as placeholders to help just create a conceptual layout prior to knowing the explicit wall types that you wish to use in that location, as well as interior wall types. In this case, let's take a look at this particular exterior cavity wall, and let's take a peek at its wall structure. So I'm going to select the Edit Type, and you'll see in the Type Properties dialog box it includes a table of information about the wall at a very high level, and also has the ability to display a preview window so you can actually see a visual representation of the wall type that you're working with. You can also use the preview button to change the visibility state of that preview window. Next, let's take a look at the structure of the wall. If I click on the Edit button across from Structure, you can see that we are now inside the wall editor. And so you're presented with a table view on the right hand side that shows all of the individual layers that make up a wall structure. And at a high level, it's divided between structural materials and finish materials. You'll also note that Revit can also keep track of the thickness, the overall thickness of the wall type, and some of the thermal properties. Every wall layer has three primary properties: its function, its material assignment, and more importantly, its thickness. Each one of these is a common property for each layer within that wall structure. So I think it's important to understand that, because when we specify the location line for walls during placement, you'll understand why it chooses a particular location within that wall envelope. Next, I'll demonstrate some wall placement techniques and behaviors. And to make this more compelling, I will open up a couple views so that you can better understand that Revit is truly a parametric modeler. So with that, in Project Browser, I'm going to open up the south elevation view, and then I'll zoom into the right-hand side just so you can actually read that these are elevation datums that actually correspond to the plan views that you see in Project Browser. So on the View tab, I can tile the windows to display both the elevation view and the plan view. And my preference is to place the plan view on the left-hand side, so I will make that the active window by left-clicking in the canvas of that window, and then going back to the window tile command will swap the views for me accordingly. Just confirming that level 1 plan view is the active view. Let's begin by placing some practice walls. Again, from the Architecture tab, I select the Architectural tool, and then in the Type selector, I choose the wall type that I wish to begin with. Then you'll see that when you start a wall tool, the options bar becomes enabled, and there's several choices that are available to us that we may want to look at before we place our wall instance in the project. So we have this idea of height that we can specify prior to placement. Right now it's going to be unconnected for 20 feet. Unconnected means it's just a user specified height that's not constrained to another datum plane like the next floor level above, which is level 2. Again, if 20 feet was not your desire, you could swipe that value and type in a new value. It could even be a low partition that might be only 3 or 4 feet high. And then the most important parameter to take a look at is the location line, which correlates with the wall definition. And so you can see that there's multiple planes that we could work with to set as the layout edge. And the most popular could be wall center line. So that's what I'll start off with. So you left click in the canvas window to set a starting point, and then left click to set the end point of the wall. But notice that when I complete that wall segment in the plan view, it automatically shows up in the elevation view. Now, let me place another instance of the same wall, but now constraining it to level 2. And notice how it shows up in the elevation view. And that's actually a parametric relationship. We'll take a look at that in a few moments. So how do I know that these two walls are the same walls that are in the corresponding elevation. Well, if I make a selection set of this wall segment in plan view, notice that its equivalent representation in the elevation is highlighting also. Likewise, if I select a wall in elevation view, it doesn't matter. It will select its corresponding wall in the plan view also. So it's really one and of the same thing. The views just help us take a look at the model from different points of view. All right, so if I wanted to take a look at the parametric behavior, if I click and drag the level 1 reference plane, you'll notice that the bottom of the right-hand wall adjusted and the left wall in that elevation maintained its 20-foot height relationship. So that's an important concept to be aware of, that walls are always hosted on a work plane, or in this case a level datum, so they don't float in space. They're always hosted by a work plane. In this case it's a datum plane. Next, let's look at wall display behavior. First thing I want to do is understand what's the exterior face of the wall orientation. So in the view control toolbar, you'll see that under detail level we can change that resolution to medium to reveal the internal layers of a multi-layer wall. Next, I turned on the shade mode from the Visual Styles pop-up menu in the view control toolbar, just to help make it more legible on screen. So we understand that the brick veneer is on the facing the top of the screen. Next, let's take a look at some placement techniques in more detail. I'm just placing a 2D detail line to act as a reference only, so that we can better understand how the wall locates itself relative to a reference plane. For this first wall instance, I'll draw left to right on screen, and I will set the location line to core center line. And let's observe the default behavior. So as I place the start point and the end point, note that the exterior face is facing the top of the screen. Now, if I place another wall instance, but this time going from right to left, I'm using the same wall type, I'm tracing over the same reference plane line, note that the exterior face is now pointing downwards on the screen. So I just wanted you to understand this directional behavior of layouts, but understand that if the desire was to have the exterior face go to the top of the screen, you can select these flip grips to change its orientation behavior. So let me show you another placement technique for that particular challenge, from going from right to left. If I place the start point of the wall and drag to the left, another way to overcome this directional behavior is to hit the spacebar key once and then go ahead and locate the endpoint of the wall segment. And this will allow you to keep the orientation facing the direction that you seek, no matter whether you're going right to left or left to right. Next, let's take a look at the chain behavior. In this first example, we will use unchained. So pick a start point, choose an end point, and allows you to draw another wall segment somewhere else, not connected to the first wall segment that you created. This also gives you more control as it relates to working with angle layouts. The way this works is the proximity of the cursor relative to the start point of the wall determines the snap increment value. So the closer you are to the start point gives you a larger snap increment. Now let's go ahead and look at the chain function. And what this allows you to do is draw multiple walls in series back to back without having to restart the wall tool. And that creates a connected wall behavior. Next, let's take a look at wall manipulations. Let's take a look at what's called shape handles. These are endpoints. When you select a wall, you can actually drag that reference point to a new location to change the length of the wall. Kind of in a similar fashion, if we place two walls that are co-joined in a common selection set, it is then replaced with a vertex grip, and then you can relocate that vertex grip to a new position and actually make it an angular wall condition. Please note that whatever action you take in one view affects all views. So if I delete a wall in plan view, understand that it also removed it in the elevation view. So it is a true removal from the project. So just be careful when using the delete key. Make sure that's what you really want to do. This concludes this instructor demo. Thanks for watching. Okay, give me a moment to clean up the environment back to the starting point. In this exercise, we practice sketching walls in plan view. We'll take a look at continuous and non-continuous wall layouts. To begin, go ahead and click the Architecture tab where the wall placement tools are located. Click on the pull-down menu. Let's go ahead and choose Wall Architectural, and then select from the type selector the exterior brick on metal stud wall type. Move your cursor into the canvas window. Let's also scan the options bar first. This should become habit for this type of tool. Go ahead and left click in the middle of the canvas to start the wall tool, and then to define that distance of 9 feet, drag your cursor off to the right. Note that if you move your cursor above the horizon line, you'll also get an angular dimension to play with. To set the dimension using zoom magnification, if you zoom out, notice that the snap increment goes to a larger value. Let's go ahead and left click to acquire a 9-foot value initially. And then the temporary dimensions that are reading in blue are an editable field. So if you left click and type in 10 feet, we can override that value. So go ahead and specify 10 feet. And then to understand that this is a cavity wall, let's change the detail level to medium so we understand what orientation the exterior face is pointing towards. All right, turning thin lines mode off just so it's back to default behavior. Please select the modified tool to end the wall placement command, and next we'll take a look at some of the selection set functions of walls. So if you place the wall that we just created in a selection set, notice that the temporary dimensions appear. That's an editable value, as well as the flip grip. So go ahead and left click to activate the flip grip to get familiar with that, and then left click on it once again to set it back. Now let's create an additional wall, and with that wall still highlighted, go up to the Modify Contextual tab and choose the Create Similar command, and we'll start from the endpoint of the first wall. Drag the cursor straight down, and let's use our direct distance entry technique. Type in 7 feet, hit the Enter key to accept. Let's place another wall. Drag the cursor straight to the right. And let's go ahead and set that to 8 feet. Continuing on, drag the cursor north on the screen or straight up. You'll notice that when we get back to the location of the first wall we placed, you can see that there's an alignment snap there. That's good to know that you can actually work with precision and create that as a design intent. Let's pull that just back from there, and then using the shape handles again, go ahead and drag that point above the first wall that we placed. And then let's reselect that wall. Select the shape handle again and drag it back to acquire that alignment snap with the first wall that we placed. Next, we'll draw a series of walls using the chain technique. So with that wall selected, choose Create Similar, and then in the options bar, go ahead and mark the box for chain. Go ahead and choose that endpoint as the starting point for the next wall. Enter in a distance of 10 feet going to the right, and then drag the cursor down and enter in a value of 22 feet. For the next segment, drag the cursor to the left and acquire that snap with the vertical wall above. The next wall segment, drag the cursor down, type in 7 space 6 for a value of 7'6". And then for the last wall segment, drag the cursor to the left and acquire an alignment snap with the starting point of the first wall that we created. And then hit the escape key twice to end the wall placement command, or hit the modified tool. Next, let's take a look at the parametric behavior of walls. Let's go ahead and select this lower wall on screen. And then holding down your left mouse button, go ahead and drag it straight to the left to acquire the alignment snap with the vertical wall above. Notice that the adjoining walls maintain their relationship to the corners. Go ahead and move the wall back to its original position to expose the alignment constraint opportunity. Go ahead and left click on the padlock to actually enable that relationship to occur, such that when you drag that wall again, notice that the upper wall moves in that same plane. So you've created a design relationship that's permanent. Next, let's go ahead and set the offset value for that corner. With that temporary dimension, go ahead and left click in that value field and enter in the value of 16 feet and hit the enter key to accept. To end the command, hit the escape key twice. Next, we'll complete the floor plan by creating the curvilinear wall as an end cap. Go ahead and select one of the exterior walls on screen, right click, and let's choose Create Similar. Go ahead and unmark the chain function. We don't need that. Let's go ahead and choose from the Draw panel the Start End Radius Arc method. Go ahead and left click to set the start point at this endpoint. Go ahead and left click to set the end point of the arc, and then drag the cursor slowly to the left until you acquire a 180-degree snap angle, and then left click to accept that arc value. Go ahead and hit the escape key twice. Let's go ahead and save the file as. Go ahead and navigate to your tutorial folder and go ahead and give it the name Walls 01 Exercise Finished, and click Save when you're done naming the file. This concludes this exercise. Let's go ahead and take a look at next steps. Reviewing the learning objectives for video 1, we were able to draw straight and curvilinear walls in a plan orientation. We were able to leverage our computer-aided design experience by using the direct distance entry method for wall layouts to define a length value for the walls. We were able to change the wall orientation by using flip grips. We were also able to create new wall segments using the create similar walls command. We were able to draw continuous walls with the chain function enabled. And then we were able to lock in design intent by applying an alignment constraint to get two disjoined walls in the same plane to behave as one. With that, let's take a look at Autodesk resources that are available to you to continue your learning path. I would like to make you aware of two specific Autodesk resources. The first one being the Autodesk Education Community, where you can access free software for both students and educators, and that can be located at www.students.autodesk.com. It does require registration, and you can use either your own personal email address or a school-issued email address. The second resource is the Autodesk Digital STEAM Workshop. It's hands-on, project-based learning across multiple industries such as architecture, engineering, gaming, and animation. And those resources are located at www.digitalsteam.autodesk.com. This concludes this exercise. Thank you very much for watching.